Hi everyone, welcome back. In this video lesson, you will learn about transformations or how to transform the absolute value function, the graph of it, okay? All right, so for the sake of time, I wrote this down. So if the value of a, this a, is less than 0, meaning it's negative, then the graph reflects over the x-axis, okay? A represents a vertical shift. So if a, the absolute value of a is more than 1, then that's going to create a vertical stretch on the graph. If, however, the value base in between 0 and 1, which means it's a fraction or a decimal that's more than 0 but is less than 1, then that'll create a shrink, vertical shrink. C, the C inside of the absolute value makes the graph shift horizontally. If it's plus in front of it, then it's going to go to the left. If it's minus, then it'll go to the right. Okay. And then D, which is the one outside of the absolute value, if there's a plus in front of D, then the graph goes up or gets shifted up. And if there's a minus, then the graph gets shifted down. So in the next few examples, it says state the transformations with regards to the parent function, and then graph each function, state domain and range using set notation. So there are three things that we need to do. One is state the transformations, 2, graph it, and 3, state domain and range. So I'm going to write some information, and then I'll come back so you can copy this down. So as you can see, this is minus 3, so that means we have a D value, okay? D has a negative in front of it, so then the graph goes down. So shift it down 3 units. So I'm going to go from the origin. If you watch the video for the parent function, I'm going to go from the origin down 1, 2, and 3, plot a point, okay? And from the parent function, I gave you a table of values, which I'm going to copy here, and then I'm just going to follow it. So if I go to the left 2 from this point, which is where the graph originates, then I go up 2. So left 1, 2, up 1, 2, plot a point there. Left 1, up 1. And then this is 0, 0, so that means this is the origin of the graph. And if I go right 1, up 1. And if I go right 2, up 2. So there we have the 5 points, connect them. And this is what the graph looks like, okay? So then this is part 2. The second thing we had to do, graph function. 3, state domain and range using set notation. So for domain, x such that this keeps going left, keeps going right, so that means all real numbers. And the range is y such that y is, now notice this went down 3, and from here the graph goes up, so greater than or equal to -3. So there we have 1, 2, and this is part 3. Okay, all right, so let's move on to the next example. So for this one, we have a +1, which means plus means it's going to go to the left. So the transformation is left 1 unit. Okay, so from the origin, go left 1, 2. So this is the vertex of the graph now. And since there is nothing in front of the absolute value, that means I can use the same table as a parent function. So left 1, 2, up 1, 2. Left 1, up 1. That's the origin, so right 1, up 1. Right 2, up 1, 2. And then connect the points. And after you have connected the points, this is the graph. So that's part 1. Okay, so that's the transformation. Part 2, we just did, that's the graph. And then part 3, domain and range. Domain and range. So the domain in set notation, x such that x is all real numbers again. And I'll save you the suspense. This will always be the case for the absolute value function. Okay, unless you're given a restricted domain to work with. The range for this one, y such that y goes from 0 to positive infinity. So y, the y values have to be greater than or equal to 0, and that's all for number 2. Number 3, this has minus. So if it's minus, means it goes to the right. In this case, right 1 unit. Okay, so it's going to go to the right 1 unit, and +3 means you have a plus in front of these, so it's going to go up 3 units. So up 3. So from the origin, let's go right 1 and then up 1, 2, and 3. So this is where the graph originates. Then there is nothing in front of the absolute value, so we can use the same table as a parent function. Okay, meaning if I go left 1, 2, up 1, 2, plot a point, left 1, up 1, so that's y-intercept, right 1, up 1, right 2, up 2, then connect the points, and this is what the graph looks like. Okay, domain again, it's not going to change, x such that x is all real numbers. The range, however, is going to depend on the value of d. So y such that d is 3 and it's positive, so it's greater than or equal to +3. So there you have domain and range and the graph along with the transformations. So let's go to number 4. So notice that this one has a negative in front of it. Okay, so we do have a negative. The negative is going to make the graph reflect over the x-axis. So one transformation is reflect over x. And then the 2, because you're taking the absolute value of a, so that would be positive 2, which is more than 1. So then this creates a vertical stretch by a factor of 2. Okay, so then doesn't go left to right, no up or down, so that means the graph goes from here. But then notice we have to change the parent function table a little bit. Okay, so I'm going to copy the parent function table. So this is a parent function table. Then since we have a negative in front of the absolute value, that tells you that we need to multiply the y values by a negative 2. Okay, so then this becomes negative 4, this becomes negative 2, this remains a 0, this becomes negative 2, and this becomes negative 4. So then cross out those values. So I hope you understood how I got these values. You multiply the y values by negative 2. Negative 2 times 2 is negative 4, right? And so on and so forth. So then I cross them out because I won't use those values. So if I go left 2, down 4. So left 1, 2, down 1, 2, 3, and 4. Left 1, down 2. And then right 1, down 2. Okay, so that's this point, and then right 2, down 4. And then connect the points, and this is the graph. So now notice the domain does not get affected by the transformations. So domain will remain x such that x is all real numbers. And the range, however, the range is going to change because now this is going down. Instead of opening up, it opens down. So y is such that y is less than or equal to the value of y at this point is 0, which is where the vertex is located. And that's all for this lesson. I'll do the other part on another lesson. Thank you for watching. Bye-bye.